Alright, time for another DraftPhysics.com, debatephysics.com. So we have a little bit of debate. Franklin Hu did make a response video. And the only downside is it's way too many subjects. So, yeah, it's, you know, and they're all at different levels. You know, I mean, there's always some underlying thing people disagree about. You know, I mean, abortion becomes a disagreement about some religious kind of notions about whether you think human fetuses have souls and all that kinds of rubbish. It's really not an argument about physical facts, or even concern or empathy for suffering or something like that. Because, of course, it wouldn't make any sense in the context of a world that endorses eating sentient animals. But anyway, so the same thing happens in any kind of subject is there's an underlying disagreement that you really want to try to get to. And so Franklin says some things. I mean, he says he's after a materialistic, mechanical model. And then he accuses my model of not being that, which every bit of it is intended to fit into that description, and I don't think there's any part of it that's outside that description. And then he even uses the term magic, which is a real trigger word, accusing me of creating mechanisms that have magical qualities. So I'm going to be triggered, and I'm going to respond to that, and so I'm going to argue my physics as it is, not as he perceives it, or not as he is going to malign it, because that's not what it is. It's so damn simple. 2 plus 2 plus 2 physics. I mean, it could be 1 plus 1 plus 1 physics, but yes, you have to account for the reality. And the fact is, there is this thing called charge out there, and you have to account for it. And I think I do account for it, rather very well, actually. So my argument is there's two kinds of force. All right. And all the force bits are exactly the same size, same mass, same momentum. So the MV of everything here is going to be the same. They move the speed of light always, unless they're encounter matter. Then they move slower because they have to push it. And they all have the same mass. And the only thing they have is a different property. There's the electron force and the I guess I should make this the plus and we'll make this the minus. So you have the electron version and then you have the proton version of the force. So just like the proton and the electron having sort of opposite properties. That isn't exactly good enough. Yeah, that's a little better. All right, then the argument is there's only two kinds of matter. So you do have your electron and a proton, and there is nothing else. Okay, that's it for the elemental particles. There's no neutrinos or any of this other crapola. There's just electrons and protons, and when you have an electron and proton very close to each other, you have a neutron. So when they're paired, they're a neutron, and they're only neutral because, they got 1 unit of positive and 1 unit of negative. And you add those two up and you got nothing. So they're dipoles. Neutrons are the smallest dipole. So that's it. And all you have is an inverse relationship between them in the sense that there's only two interactions. So if we just do the electron as the example, when the electron force hits an electron, it sticks. Alright, so the force is going the speed of light. It sticks to the electron. It now shares its momentum. So that means that this is going the speed of light. The velocity is the speed of light. Well, now it's going to be less than the speed of light. So if we said this had the same mass as the force bit, then we could just say that it's now going to go half the speed of light. And if there was two of these, then there would be 2/3 the speed of light. And you could just get closer and closer, but you'll never get to the speed of light for an electron. The point would be is that it sticks and it pushes. Now if it encounters a force bit coming the opposite way, that's green, then what is going to happen is this force bit is going to reflect, just like a kinetic reaction, and this one will reflect, just like a Newton's cradle. The two will just bounce off of each other's force, so to speak. And so this one will be gone, and this one will be gone, and you'll be left with the one pushing kind of idea. So as you encounter force, you lose your momentum. Okay. So the electron is dead matter. It doesn't have any power of its own. It can't keep going anywhere. It only goes where the force pushes it. So if there's extra force coming from a direction, then the electron will likely move in that direction. If there's no extra force, it'll just wobble back and forth. Alright, so that's one interaction. Now if the red bit hits it, so if a red bit comes in and hits an electron, it goes right through and it comes out a green bit, okay, an electron bit. Alright, and so that creates your perfect charge scenario. So if you just do the same, inverse this for the proton, you'll figure out that it creates the idea that protons constantly either just reflect, that is, if a red bit hits, it bounces off if it's moving in that direction. If it doesn't, it sticks and the proton moves. So you only have, so basically what you have is you have a proton will always be reflecting to the universe red. So no matter what color comes in, alright, green can come in, but red's going to come out. So no matter what happens, it's always radiating red, and the electron is always radiating green. And the green is inert to the proton. It can't push the proton. It goes right through and turns to red. And the red goes right through the electron and comes out green. So they're inert to each other in the sense that there's no pressure between them. Nothing can ever reflect between them. So obviously the external universe creates pressure that'll push them together. And obviously they'll repel each other, because if I took two electrons and put them next to each other, the force will bounce back and forth between them, and with each hit it's going to impose momentum. So it's going to create momentum between the objects and push them apart. And the closer together they are, the more pushing they're going to get. The more momentum in this direction away from each other. So there's nothing magical in two kinds of force, two kinds of matter, and two interactions. That's not exactly magic. Now if you're going to say it's magic to say there's a force moving the speed of light, well, I would argue it's no more magical than a domino, like you're saying exists in the universe. There's a bunch of dominoes and somehow you moved one of them. Well, it's just as magical. How do you account for its movement? How do you account for any of that? I wish that green was a bit darker, but anyway, good enough for the argument. So, I've reduced very complex standard model, all the other bullshit, no entanglement, no wooey, no nothing. There's no magical force that ties things together, no attraction, no repulsion. It's all made out of a physical event. Physical things bouncing around. It's a push universe. Explicitly argued. There's no such thing as a pull. Okay, so it's only things move because of momentum. MV, momentum. It's just about momentum. The entire universe runs on one thing, momentum. Little bits with momentum moving the speed of light. Big bits get momentum by collecting these little bits. You collect the little bits, you gain momentum. And that's all there is. And so I'm not going to be accused of magic. There's no magic in there. Simple little rules. 6 rules. Little force bits. Again, I could make it 3 rules technically. Alright? Force, matter, interaction. That's all there is. 2 simple little interactions. So, alright, so we'll get to some of the other subjects now, but I had to throw that in just because, yeah, I'm not going to call bullshit, but it's sort of a bullshit accusation. You got to be you're going to accuse somebody of magic, invoking a magical phenomenon in this conversation where so many people provide so few details. So I'm going to call you on some of your absent details and say, well, what am I supposed to think? How does your thing work except for magic? So I'll throw some of it back at you. All right, so I guess the most fundamental part of a communication problem, a failure to communicate between me and Franklin in terms of everything gets broken in terms of an ability to talk about any subject, is the idea of this distinction between people that have an ether theory and, I would argue, I have a, there's three-dimensional space and it's empty, and there's discrete bits of force in it, and there's discrete bits of matter in it, and the force and the matter are interacting in the empty space, and there's no ether, so my problem with ether is I don't know how do you make the distinction? So I've never seen anybody draw their construction of ether. So, I mean, they should be able to draw some idea of it. Now, obviously, you could make it just a geometry. You could just turn the whole universe into a bunch of little squares and just say, this square is matter. Well, what kind of matter? I mean, you can't, so the first problem you have is how you're going to make your ether and the distinction between the force, the ether conveying a force. So it's really easy for me to say the x just moves from here to here, and then it moves to here, and then it moves to here, and it moves to here. So you did some vibrating like a domino. You just move the energy from one square to another square to another square to another square, and you can make something move that way. But what's the distinction? Again, what is matter then? What is, how do you make matter out of this? Because isn't matter going to do that too? So what's the, how do you draw the difference between what is empty space, which you're saying isn't empty, that it's full of this stuff, and matter? Is matter an absence of the stuff, or is it stuff? So, so I don't even know how to, I don't even know how to even imagine it. I mean, what you're doing to the atom is so strange that I don't know how to place it in space, because you're saying it's made out of these things, electrons and protons, and some sense of that, and then you're saying out here there's a whole bunch of this positrons and electrons and all that stuff right here next to it. It's all filled into the space. And I'm just saying, what's the distinction between the two? And you seem to have an opposition to just moving something from point A, to point B in space, in empty space. So there's no empty space between all this stuff. It's all stuck to each other. Or, I mean, if you're going to allow your positron or your whatever to move from point A to point B, then aren't you just recreating empty space and then putting a bunch of clutter in it for no good reason? And then clutter, you have to concede, does require energy to move. You can't move positrons or electrons without applying energy to them. So, I don't know. So I can't make any sense out of it. And so I made two of the simple arguments that, one of the reasons I can't make any sense out of it, just no matter how you do the geometry, whether I make the checkerboard out of squares or circles, I'm still going to have the same problem. And that is, I can't make a geometry. No matter where I put no matter how I space the pieces, I can't make straight lines in any direction. And so you'd have very limited directions that you could push something. Now, Franklin said, well, computer screens prove that, and, no, they proved my point, okay, because they actually do have at least lines. That is, to make a straight line, you do this, So you have to explain how your energy knows to do that. That somehow your energy knows to go this way, and then it knows to go up. And then it knows it's supposed to go this way, and then it knows it's supposed to go up, and then it knows it has to go this way, and then it has to go up again. How does it know all that? How does it know that it really wants to go this way, and to go that way it has to go this way and then this way? How does it know that without that being magical? Where do you get that magical property from? That somehow it knows you're not really going from square to square, that somehow you're going, in some other direction. That you have a location you want to get to, and somehow it's going to get there by wobbling all over the place. I don't think so. I don't think it makes much sense. And frankly, again, I don't see any need for it. So again, I just can't really understand why put all of this dead stuff in the way. And if you make it alive, that is, if you give it energy, then, you know, because you still have to make gravity, you still have to do all this other stuff that's going on in the universe. So all this stuff has to, I just don't see how it can work unless you give it energy, because frankly that's where the energy always has to come from, is the outside. It has to come from the space. It has to be in space before it gets to something. And so I think you can see in a previous video that he does get the push idea. That push, okay, is a really simple idea, hitting something and pushing it. And that pull is not. That there's no elemental construction of a pull. They have to invoke magic. You can't make an elemental pull. You can't hit something and make it come towards you. Momentum don't work that way. Alright, so that's one of the arguments. I guess it's just not a satisfactory answer to say, well, there are at least lines. Alright, and then in another example, the wave example, he uses, you know, these idea that you can create a cannonball of pressure in, like, say, a swimming pool. You could take a bunch of dye and you can create a very quick motion, like a cannon shot, and you'll get a swirl of energy that'll move, okay? And so it won't move, like, it'll be just a ball, and the ball will essentially, the ball of color will move, and then it'll dissipate. It's not really a wave then, is it? Okay, so that swirly thing moving through the water isn't really a wave, because it's not relying on the wave function, which is, the wave function is just moving stuff up and down and creating the illusion of motion in a direction. These bits don't actually move in this direction. The water doesn't go in a direction. The only thing that moves in a direction is the wave. That is the pressure that says push up into gravity, push up into gravity, push up into gravity. So the real pressure is in the water. The water's going forward, okay, underneath the wave. And because it can't go forward without higher pressure, it has to go up, because that's where there's less pressure. So it pushes the water up. All right? So that's the only motion, is that, yes, the water underneath has a movement to it, but it's only a short movement, then it goes up. But that's what the wave is really something that is riding on this simple motion of the pressure moving in a direction. The going up is moving, but there isn't anything moving explicitly in this direction. Technically there is. I mean, some of the water is moving, but it's taken a long way. All right. It's always exchanging with other molecules, you know. So you don't have this food coloring effect. I can't take blue water, blue colored water, and create a wave in it and have the blue water go with the wave. It won't happen. So I think that's an important distinction, you know, where that doesn't really satisfy it. And so when you say, you know, you don't accept that as an explanation for photons, well, what do you think photons are doing then? Or do you think they are exchanging pressure? That is, this pressure causes something to push into something else, and that causes something to push into something else, and that causes something to push into something else. Or let's say they just get fatter. They get fatter, they get fatter, and then they get smaller, and they get smaller. I mean, or do you think there's an actual thing that actually moves from point A to point B? Is there a physical thing moving from point A to point B, or are you just moving motion from point A to point B? And again, that's a huge distinction. And if you're moving an object from point A to point B, it's not a wave. All right. And again, I think you're still stuck with any motion you create in an object, in space. if it's just a wave, it's going to tend to have motion in more than one direction. It can't just be going this way. It has to end up pushing motion in other directions. So I think you're going to be in trouble arguing even if, the domino thing. Again, you're stuck with the problem of creating straight lines if you're relying on a bunch of atoms conveying the pressure, because it won't do it in a straight line, because there's not the benefit of a water surface in gravity. You have to explain how it happens without a water surface and without gravity. What keeps it from, if I'm pushing water up into gravity, gravity's going to push the water back down. But if I'm in space and there's no gravity to push it back, how can the change in direction possibly return? If there was no gravity and I pushed on the water would just go forever. It would just leave the ocean and fly into space. So I wouldn't be able to make a wave. I wouldn't be able to make that standard drawing of something moving in this direction and also going in this direction. You can't have it all three ways. Alright, it was probably more words than that was necessary. It's one of the liabilities. So I'll see if there's some other subject I want to tackle. I think I just want to tackle the idea that we really have to resolve some. I mean, you really, if we don't have any common understanding of any of the elemental bits, it's like, well, maybe the argument is kind of pointless. There has to be some kind of agreement on some kind of mechanical fact. Alright, well, I'm going to be a tiny bit self-indulgent. Yeah, right. And just to argue a point, I think, I'd like to get Franklin's opinion. So I've tried before to get him interested in this 1/2 mv squared versus the simple Newtonian mv. Alright, and I would argue that this was always the truth, and they had no good reason to do this sloppy crap. And this is it's really important, because this is inside the core of physics and quantum mechanics and relativity. I mean, it's just in the core of it. It's all over the place, this squared velocity nonsense. And so if this can be defeated, it really is an opportunity for all the dissidents who are arguing for some other truth. Well, this is the way to crack the door open, okay? This is the way to put them on their defensive, is if you can prove that this was a mistake, a 300-year mistake, that they never really looked into it, they never tried, they never proved that it takes 4 times more fuel to go 60 miles an hour than to go 30 miles an hour, 4 times more, not twice as much, 4 times as much. They never demonstrate any of this stuff to be the truth. And, so if this can be proven wrong, it's huge. That their whole work equation is wrong. It's not work equals force times distance. It's work equals force times the time the force is being applied. Time. And that's the same truth for gravity. It's how long you're in gravity that decides how much gravity is going to affect you. Alright, it's a huge mistake anyway, and it's just a glaring, gigantic credibility flaw. And so it does put all of the subjects back on the table to be argued, because obviously if they could make a mistake this fundamental, this elemental, and make it in such a bold and fantastically stupid manner, it makes them incredible. So look, the simple argument, Franklin, is, alright, so let's say I make a train in the shape of a piston, okay? And so I have 2 This is one train, and it's made out of just these two pistons. Okay, and so each piston, let's just say, weighs. I gotta remember how I want this to come out. Yeah, it weighs 5 tons. Okay, so the big heavy pistons. Doesn't matter what they weigh. It's 5 somethings. All right, and I'm gonna push this train at 5 miles an hour. All right, so it's a total of 10 tons at 5 miles an hour. All right, and I'm going to push it into a device, okay, that's really just 2 holes, okay, for the pistons to go into. All right, and the rest is just filled with fluid or air. It doesn't really matter what I fill it full of. And on the other side, I have 1 piston. Okay. So what's going to happen is these 2 pistons are going to go into the cylinder, create air pressure, and I have sitting here, okay, another piston, another 5-ton piston, just sitting there. What's going to happen when this piston goes in? Well, this piston's going to fly out at 10 miles per hour. That's what's going to happen, no doubt about it. All right, so it basically proves that I can take 50 joules of energy. Let's just say represents 50 joules, and I can make 100 come out the other end. And I don't have to do anything. I don't have to add anything. I don't have to do anything. I make free energy. So this formula ends up making a very simple device into a free energy device. And there's no doubt about it. So if I can prove, and I think this experiment proves, that I can make a 5-ton train going 10 miles an hour using a 10-ton train going 5 miles an hour. So I can use something that only has 50 joules, and I can make something that has 100. I mean, the actual numbers are different, but it's exactly this amount. This is twice as much energy. That's what this formula says. This formula says this has 2x the energy. All right, and clearly it do not. All right, because clearly I can create the 100 joules with only 50. And that's not possible. So this simple experiment proves the case. It's a decisive proof. Nobody's going to counter-argue it. It's just so obvious what happens. There's no way to escape what happens. I mean, these 2 moving 5 miles an hour is going to create a displacement here and a displacement here, and that displacement is going to obligate this to move twice the speed. So it's the same as the lever argument, but frankly it's so much more visually obvious. So you could do it with walls, just closing walls. And the difference is that I can have 2 walls moving 5 miles an hour, or I could just move 1 wall at 10 miles an hour. I compress the same amount of air. I do the same exact amount of work. The walls get closer by exactly the same moment of time. Each moment of time there's the same exact amount of space that's being compressed. It's creating the same exact amount of pressure. 2 walls moving at 5, 1 wall moving at 10. Same pressure. Exactly the same energy. Proving 1/2 mv squared cannot possibly be a correct or accurate definition of energy. Can't possibly be correct, or we'd all have easy to make free energy devices. So I just like your concession that it's true. I have defeated 1/2 mv squared, and it's time for everybody to celebrate the fact that the pompous, arrogant, talking head bullshit of science, they've got a big fat failure sitting there. They failed one of their fundamental tests, and now they're suspect. And it's time to talk about all these things they're telling us we must believe, or we're idiots or fools or unscientific or illogical because we don't believe in their entanglement. We don't believe in all this crap they tell us is the truth. All right. He's throwing that in. yeah, it's really quite important. I mean, there's really no point, right? I mean, in all of these discussions, the whole point of the dissident community is to prove them wrong about something, and I have done that, and no one cares. I mean, it's just amazing, that just isn't something people get behind, because I guess their agenda is they like 1/2 mv squared because it is kind of magical and fun. Where I look at it and I just say it's convoluted and stupid. Squared velocity? Why would I square a velocity? It's not. Velocity isn't geometric. I can't square it. I can't square it for some reason. There's no reason to square a velocity. Alright, so I guess I'll play a little clip here of Franklin speaking and just point out how, yeah, it just didn't really satisfy me as an explanation.
Exactly. Light is that, it's like a ray. It's like this pen. So it's longer than it is, say, skinny. It points in a particular direction. It occupies a finite amount of volume and space, right? So this is what we mean by a ray, okay?
Not entirely. So, because, yeah, I still don't see where the frequency comes in, in terms of obviously you would need some way to know where the beginning and the end of the ray is. If you're going to say it's that little short duration of something and say the frequency is its length, well, then you're stuck with the idea that, there's mile-long radio wave rays, and, of what? Of a substance? So again, see, to me, it's just so easy to say it's just a frequency. So I'll just make the counter argument that I'm just going to say a photon is just a frequency, and and the wavelength is just the distance between the bits that are the energy creating the frequency, and that's just so simple. That, that's a photon. So maybe we could agree that, well, see, we won't agree, but you should just shoot a photon as a pencil. See, I'm arguing, when I say the word photon, I'm not saying a photon this is a photon, P, fair, photon, one object. It's not a single object. It's made out of these force bits, the bits of force. All right, now I'm arguing they're all moving, maybe we could agree on this, that gravity, electricity, magnetism, and light are all moving at the same speed, okay? The interactions take place at the same speed. So I would argue that all of these things are the same stuff, and you're just talking about arranging them differently to create the different phenomenon. So it's just that obviously light is at a frequency. The other phenomenon has characteristics that make them possible, but it's just the same stuff causing the pressure, causing the impacts. And I'm just, obviously arguing that the difference between red and blue light is, this obvious difference, right? Is that this takes up half the amount of space. The blue light, the events happen quicker, which means the tipping point argument's pretty obvious. Bang, 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 I can tip it over. If I go bang and let it swing, and then bang when it's swinging in the wrong direction, I'm not going to tip it over. So this is a tip. You can tip it over with this. If you throw rocks this way, you can tip the pole over. Throw rocks this way, the pole just swings back and forth and it doesn't tip over. So that can be understood why this has more energy. Now, it doesn't technically have more energy because it's still just this, this, and this. It's still just a mass with a velocity, a mass with a velocity. It's just still a quantum, 1, 1, 1. Still adds up to 3, in terms of energy. But obviously, putting the energy in a different form matters. Now, you're saying, okay, that let's just say whatever the matter is, I'm not sure whether you accept the standard model. I don't accept it, certainly. I think of it as magnetic, that things aren't swirling around and all that crap. But whatever, we're saying that, okay, there's action. The photon is created. Now, I'm arguing that there's no way the photon's created by an electron. Okay, it's creating one of these. Okay, so this atom moves an electron. That electron pushes into the space, and it pushes these little bits into the space. So it makes a compression. So where they were spread out like this, okay, because the electron moved, they got compressed in terms of their reflection. So they came in this way. They're going to leave this way. All right. And if more than one atom does that, you can sort of understand that now you'll have these bits of pressure at a sequence. So you'll have the bit created here, and then this one a few milliseconds later does the same thing, and it creates a compression in space. So when this one's moved to here, this one creates another one. All right, and then there's a third atom, okay, that does it again. And now this becomes these elements. And so you have this bunch of stuff, this compression. So you've compressed the force bits into a smaller space. They're going in this direction, and they're going at a different time because you've moved electricity this way, and it takes time for the electricity to move, the speed of light. So it bang, creates this one. Bang, creates this one. Bang, creates this one as it moves. And that's the polarization, is the fact that they're not exactly lined up. So, yeah, I didn't really want to be arguing my theory, so that's what we always end up doing. So what I'm saying is I don't see anything in your pencil. So the problem with your pencil is, what are you arguing? So if you're arguing for a matrix, a universe made out of stuff, and only stuff, and that there's no nothing. There's no empty space anywhere. There's just stuff connected to stuff, ether. Then you have to explain, is the pencil pushing the ether out of the way? Is your photon moving the ether? Or is the pencil a vibration in the ether? That is, the pencil is here, and then there's a new image of the pencil here, and then a new image of the pencil here, but the pencil never goes anywhere. The photon is just a composite of arrangement, and you're just moving the pattern through the ether. So are you arguing that the ray is just a pattern that moves through ether? Or are you saying it's actually matter, and the matter plows through the ether, makes waves and plows through the ether? So is it matter that plows through the ether, or is it pressure? Is it some kind of pattern in the ether, and the pattern is being pushed in a direction, okay, through contact? And it has, I guess the frequency would be the duration, like how long you if I'm trying to think of like ringing a bell or doing something where you hit it and you're causing this vibration to travel that has a certain frequency built into the size of the vibration, the quickness with which you hit it. If you hit it really quick, then it's a little short thing. If you hit it slower, it's a longer thing. But then you get into the argument that the longer thing should have more energy than the shorter thing, because you're not really saying the frequency is made up of components. You're saying the frequency is just one object. So you're kind of arguing for a photon as a size of a thing, and saying that a big photon, okay, a photon with a big wavelength, red light, is big, all right, and blue light is small. Then I would counter argue, well then how come blue light does more work? Because you can't make it go faster. So red light would end up being more massive, so you would argue it has more momentum than the blue light. So it should be more energetic than the blue light. Well, anyway, I guess the key point to ask is, does the photon plow through the ether, or is it a pattern manifested in the ether? So it's not really the same elements, the same electrons, or whatever. Let's see, you're making photons out of something I don't believe you can make them out of. Whatever you're saying the photon is made out of, does that actually travel, or is it just a pattern in the ether? I don't know if it really matters what the answer is, because I still don't think a photon can be understood as anything other than a composite object. It's made of quanta. It's not a quanta. A photon is much more than one quanta of energy. That's why it creates a whole piece, a whole volt of electricity. I mean, it has to create a minimum amount of, a Planck minimum amount of detectable electricity. You're not going to do that with one Planck quanta. But you might do that with 5 Planck quanta. Anyway, or 3. Alright, so let's see if there's anything else I need to bring up. Sorry, it's just hard to make a short video. Just hard to do. Alright, so I'll try to finish up on this bit. A little bit on superfluids and friction. I think friction's a really interesting subject, frankly. How everything just loses. Momentum is something, energy is something you possess. And so you capture it. The little force bits have it. You capture the force bits. Now you have it. And now you can give it away like you can give away money. And friction is just a way of giving it away. Okay? Friction isn't a counter force. It's just you giving away what you have. Direction. Motion in a direction. So I'm sort of arguing that, frankly, anything that's moving is really displaying heat with a direction. It's directional heat. I mean, heat is, technically, it's like, energy going in all directions. Well, if you think about it, it's really energy going in one direction, like fish swimming in one direction. It's not heat anymore. It's motion, And so motion is just heat in a direction. Directional heat. So what do I want to say about this? So he's talking about superfluids and, a way of evading friction.
If just looking at ordinary particulate mediums like water and air, right? You wouldn't think that a current could go around forever with no losses. It's got to be hitting the atoms, but yet it does. And you have things like superfluids, which flow with liquid helium, which flow with absolutely no viscosity, and probably liquid helium would probably...
Yeah, but see, none of those display any of those functions without you putting energy in. So they're not very good storage. They don't store energy very well. Frankly. So again, and then the major argument would be let's say if I make this universe out of ether, you have all these different components. Okay, you have magnetic, you have radio waves, you have all these different things flying through the same medium. And how does the stuff not interfere with each other? Because you've got to be making it kind of different. They all have to have a different frequency, or they have to have a different something about them. And if they have anything different about them, that means they can't just hit each other and perfectly exchange their direction, right? So I could argue that if I make a universe out of force bits, the force bits could hit each other all day long, and it wouldn't make any difference, because if this one's going this way and this one's going this way, then this one will go that way, and this one will go that way. They'll just exchange direction. So it doesn't matter whether they hit head on, they could just exchange direction. So the universe looks exactly the same whether they hit each other or they miss each other. It would look exactly the same. So if there was no matter in the universe, and you bought into this argument that there was force in the universe, the force wouldn't do anything. It couldn't evolve into anything, because it wouldn't matter whether it hit or it didn't hit, because every outcome would be the same whether it hit or it didn't hit. Whether it passed right straight through each other or whether they bounce off of each other, the outcome would be exactly the same if you obeyed a perfectly kinetic interaction rule. So, but in your theory, you're not going to have that advantage, because you have a bunch of different things. You have a big frequency photon and a small frequency photon, and then you have all kinds of, magnetism and gravity, whatever you're making those out of, flying through this space. And how are they not going to interfere with each other if you have only one ether to work with? I mean, that's sort of why conventional physics created a field for every single particle, is because one field doesn't work. Now, for me, it works just because I've created two fields, essentially by just creating two kinds of force to go with the two kinds of matter. And now I can create the inverse reactions. And the two can stay separate, as if they're in a separate dimension. The red force never interacts with the black force. So only black force can hit black force, which makes it mean nothing. Well, I won't go into all that, but whatever. Just saying the real problem is that if you have different things, you know, circle hitting line, or you know, you have different modes of mechanism hitting each other, then you don't have a Newton's cradle anymore. You don't have a capacity to exchange, and anything, they'll constantly interfere with each other. So photons should interfere with photons, especially photons of a different frequency. I should be able to shoot red light and blue light and have it crash into each other really easy, because they're traveling through the same ether, and they can't Newton's cradle because they're not the same size, they're not the same mechanism, they're not made of the same stuff. Or are they? You know. Yeah. All right, well, anyway, I appreciate the conversation. Sorry these videos are a little long, but don't know what to do about that. I just, frankly, it's physics. I just don't know how you could talk about it quickly and do it with any utility, I guess, would be the problem. It's not very useful. Yeah, so the real problem is we probably ought to just find one subject and beat that one subject to death. So maybe just all the arguments for and against ethers. Maybe. I don't know. Yeah, we'll see. Anyway, till the next time and such. This has been at DraftPhysics.com, DebatePhysics.com also. But yes, debate does have to be on one subject at a time. Or, it does get messy.